Hello, everybody. I think everybody knows me, and my name is Michael Yue, and I'm the maintainer of this of the WasmEdge project. And so here's the day after July 4th in America, and welcome everybody to our community meeting. So we have some very interesting topics we want to discuss in this community meeting. So basically, we'll start with two technical topics, that's related to the new release of WasmEdge, and those are the things, interesting APIs that you can use immediately in your application. And then we're going to talk about our community ambassador program. So yeah, without further ado, let's get started with the first topic. The first topic is Wasi-crypto or WasmCrypto. Wasi-crypto. So it's let me see that. Yeah, it's called WasmCrypto. Sorry. So so the idea really is to provide cryptographic APIs like calculating hash and encryption and all those basic APIs that you want to keep your data safe into a WebAssembly application, by exposing the underlying platform's crypto API into Wasm. And there's very broad application use cases for that. For instance, you can use that to implement HTTPS, TLS, which is what we do. And you can also do things like blockchain applications, and also use them directly to protect your data. So yeah, that's area we have been working on since the past, I think, at least 3 months, and now we are finally having all the API implemented and having it ready to release with this version of WasmEdge. So without further ado, I'd ask Mr. Renshuo Yang to get started with his presentation. Mr. Yang has implemented this whole spec, and so he gonna tell us what it is and how to use it, and yeah, please.
Okay, so let me share my screen.
Okay.
So it's a simply sorry, it's my first time to share about our meeting, so I will talk about it. So the first question is why we need to use Wasi-crypto instead of just use them in WebAssembly. You may think that implement them in WebAssembly is simply enough, or you can also simply just make OpenSSL or similar crypto library into WebAssembly. But however, it have a low speed. For this question, I believe the biggest impact is speed. I previously used Wasi-crypto's interface for benchmark, and if you use Wasi-crypto as a backend, you will have a way some speed up. This so the main speed up is inspired by the hardware acceleration. So thanks to Wasi-crypto in WasmEdge, we use OpenSSL as Wasi-crypto's backend, which implements hardware acceleration for those operations, which means I rarely away some speed up. So if you also need to access some system level API, you will need to use it. Sorry, I'm a little too.
Don't worry, just
okay.
Talk slowly. That's fine. Yeah.
You can access system API for if you ask open system for your reserve your private key or something else, so this is why Wasi-crypto. For most people, I believe the speed is the first impact about crypto. So this is why we use Wasi-crypto. We are talking about Wasi-crypto's interface style. It has a POSIX-like styled API. For almost every function, it uses an error code as a return value, and a handle. For some special function, it will return a handle, which used to operate on this API. So we can talk about how it works, share about this. You will see how to use this API. For the first, I will talk about the basic info. This is the first API about Wasi-crypto. Wasi-crypto reserve all data in host side, which means we can access it easily, like OS kernel. If you want to access kernel side data, you must use system call to get it. So it's similar in Wasi-crypto. If you want to access data in host side, you will use array output, which is a special handle for those data calculated in host side. It has two API, two interfaces. So first is array out length. Give you the length of you allocate on the buffer, on the memory, allocate on memory. If you want to pull that, get them, you can just call array out pull. And out is the silent side reserve buffer operation. So now you can get after call, you will get all data in this buffer. So this is the first. The second is options. Options is represent as a key value map, which means if you want to add some extra action on function call, for example, such a function, you wish it to do more things, you can put a key value in options and then use this options handle to open this state or such an interface. Okay, so this is the two handle is the basic handle used for Wasi-crypto. And now we are talking about some crypto related function. If you want to make a crypto related algorithm such as hash and HMAC such API, you will call this state open to semantic state open to get a state. This state is also a context state or context. You can call it and this will use for our most action. If you want to do a hash related, you just need to use semantic state open. You will tell which algorithm you need to use and options for this state. In fact, hash don't accept any actions, so we just need to put nothing to it, and they will get a state handle. Then you will put data in it. You can put any size data in it by code semantic data absorb, and then you can squeeze out. This is for a pattern for hash function. For all semantic algorithm, you can call such function in it. You will find it in proposal. So I will not talk too much about it. I just want to talk about the pattern to use it. For those all state it accept are open to create it and accept are closed to find out to close them. And if you want to clone, you can also clone them. This is a deep copy them, and it also needed to close. This is all about semantic. Just call open and other state operation, and after used, you can just call close. Another is a semantic. A semantic can divide into three modules. The first module is used by other two modules. So first is secret key. First module represent all the key data. If you want to import a secret key or public key or key pair, represent the secret key or public key or key pair. They are all represent data in a asymmetric operation. So this is all type. You can call secret key importer or public key importer or key pair importer. They are all imported by call such function, and you will need to specify which arrangement type. This arrangement type you wish to use. It can divide into signatures or key exchange. These are two other modular. So this is represent secret key. If you don't want to use them, or after use you want to close, you need to close them, just call close function. You will see that all they can close, key pair close, or public key close, or secret key close. This there is no recorder. So for the next, they are also can transform each other. If you want to get a public key from key pair, you can just simply call key pair public key. Let's say there is no record, but this function is exact. So you can produce it by call key pair such a function. You will get a public key handle. They are all handle based. So, and for other two modular is about first we talk about key exchange. You can call Hellman based key agreement. You can exchange key. If you want to exchange key, you can use this. This will generate a shared key secret handle key by call this function. You either accept a public key handle and a secret key handle and get a shared secret key handle. And you can also use this for key incorporation missions. So this is for a more advanced way to exchange key. They are all used for key exchange. This is for second modular about it. It's about signatures. So this is first is state open. This is like symmetric state. Like symmetric state operation, it have a symmetric state open and a symmetric state close to create or close these states. It absorb data, but it just have one function because it's easy than symmetric relative action. So you can call this to absorb data, absorb a message. It can call a many calls to absorb message, and then you can call signature status thing to show computer a signature for all the data. So this is how to create a signature on Wasi-crypto. If you want to verify a signature, you will also need to create a state, a verified state. This will open, create a new state, and then absorb a message to absorb same message like you here update, then to check about the data the data's signature is valid. You also need to close them after use. So there is some example usage to talk about how to use them here. So this is okay. So this is today's I most share about. Sorry.
Oh, thank you so much, Wenshuo. And yeah, this is as you can see, this is very comprehensive, and a lot of work has gone into that. Those are, very important basic low-level APIs that gonna enable a lot of work that we're gonna do in the future. And so what I'm particularly excited, that's got me excited immediately was signature creation and signature verification, because as you know, we want to use WasmEdge in a microservices environment, and a lot of those other web services would require authentication from the caller, right? That's so they would have key exchange and ask you to sign your request, and as you can see from a lot of those web services APIs, when you construct HTTP request or HTTP GET or POST, you have to have a user secret key to generate a signature to prove this request come from you, right? So this this API would make it possible to do it within Wasm, and then the whole PKI public key infrastructure and the symmetric encryption that you have just talked about would provide the basis for supporting HTTPS and TLS in WasmEdge. In fact, we have an open issue in GitHub at this moment. So if you guys are interested, you can just go to GitHub WasmEdge/WasmEdge and then search for TLS. And the idea is to have a WebAssembly-based TLS implementation that would in turn be used by higher level HTTP libraries. And it will be structured very similar to the Rust TLS library. The Rust TLS library, in fact, is depend on a native library called, I think, I forgot which one it is, but but depends on native cryptographic library. So so there are lots of things that we're going to do with this, with this API ready, and with this serving as a basis for a lot of our future work. So yeah, thank you. So yeah, let's so if anyone has questions, please speak out, or you can wait until the end of the talk to discuss things that you want to discuss. Okay, so let's get started with the next topic. So the next topic is Wasi-nn. And Wasi-nn is a very, very interesting subject that we have been trying to work on it on and off for the past, I would think, at least past a year and a half now. And most of one of the most important use cases for Wasm on the edge cloud or on edge devices is AI inference, because Wasm is fast and so it's ideally suited to handle computational intensive tasks, and cryptography is one of them, and AI inference is another one. So from early on, we had integration with TensorFlow, so which allows you to use TensorFlow models to do inference, not for training but for inference, in our Rust SDK and also in our JavaScript SDK. So basically you can write a Rust application instead of a Python application that reads the image and then send the image to a TensorFlow model and gets the inference result, right? We have numerous demos on that, and we have, in fact, we have numerous real-world users using that already. However, that's a very WasmEdge specific approach, and also, TensorFlow is just, although it's very popular, it's just one of the AI frameworks out there, right? There's other arguably more popular ones, and so about 2 years ago, I think I think that was even before the Bytecode Alliance was established. There was a proposal from a community that's sponsored by Intel that talks about standardize the AI inference work within all Wasm runtimes. That's called Wasi-nn, Wasi neural network, right? It's first implemented on Wasm time, and with Intel's OpenWino, that's Intel's TensorFlow, right? So Intel's AI inference framework. So, but it provides enough flexibility that it can, in fact, support other frameworks beyond OpenWino. So, for instance, ONC in PyTorch and PaddlePaddle for Baidu, and all the other tensor-based frameworks. So we decided to implement Wasi-nn, and another very significant factor is that, as you have heard from Haidai last time, in this version of WasmEdge, we provide a modular plugin structure so that the users can decide which extensions that he or she wants to add, and Wasi-nn is one of the first proposals or extensions that is written in that way. So because as you know, TensorFlow or OpenWino all have dependencies that could be fairly large. So we don't want every WasmEdge users to have to install them. So so we have we also have a new installer and have a new modular approach that help users to pick and choose which extensions and which features they want. So that's that's enough for me. I have a this is so I want you guys to hear from the developer who actually implement this for us, and work on Mr. Ye. That's I know you have been working on this for the past past 6 months. So let's let's work on Mr. Ye to give us introduction of what is Wasi-nn and how we implement it in WasmEdge, and some examples on how to use it. Thank you.
Okay. Okay. Can you guys see my screen now?
Yes.
Okay. Okay, let's start. Thanks, Michael, and thanks for your detailed introduction of Wasi-nn. And I got a feeling that there is actually not much thing left for me to introduce. But anyway, so hi guys. My name is Jianbai Ye, one of the mentees in LFX mentorship of Wasi-nn. And today I'm going to give a talk about the work that I have been done so far of supporting Wasi-nn proposal in the Wasi-nn. And so this is today's outline. We will first discuss the reason why we need the Wasi-nn proposal in the Wasi-nn, and then I will use a quick demo in Rust language to show the usage. At last, we will discuss about the future works of the Wasi-nn. We can play around in the Wasi-nn. So first, why do we need Wasi-nn in the Wasi-nn? So the abbreviation of NN in the Wasi-nn stands for the neural network, which Michael have introduced before, in fact. But neural network is actually the most popular technique in the modern age deep learning, and so we can do many things with deep learning. And there are efforts to pour deep learning into the Wasm. For example, like the TensorFlow.js. But the Wasi is actually dealing with a conceptual machine, so we cannot take advantage of any CPU instruction, well, for the peak performance. And so that's the first reason. And the second reason is that, well, there are some processing device like GPU or TPU in the Google may be required by some big deep learning models, like those, well, pre-training language models. So and Wasm right now is unlikely to compare to those non-CPU device. So I just briefly give two reasons I think that maybe we why we need Wasi-nn in the Wasi-nn. And also, so that's why we need to introduce Wasi-nn. So Wasi-nn is a set of quite flexible graph loader style APIs. So graph loader style means that we don't actually implement any low-level operators or neural network layers inside Wasi-nn. So we only focus on reusing the compare models. In another word, we shifting the work of compiling the models to another tools like OpenVINO or PyTorch or TensorFlow. And Wasi-nn only focus on loading those compare models from different machine learning frameworks and do the inference. So by doing that, we can actually reach the peak performance at the runtime, and we can have a better understanding of the Wasi-nn's APIs by looking at the figure on the right. So those APIs relationship are quite high and linear. At first, we deep learning models and its corresponding device, for example, like CPU. So they will construct a graph, and then we can instantiate executable context from that graph. So after that, once we have the context, we can blind some input tensors and run the computation, and finally we can retrieve the results. So that's pretty much, well, all the APIs in the Wasi-nn we need to implement right now, and that's how it works. And also we prepare a Rust demo, well, later for a glass of the usage of Wasi-nn step by step. And you can always find more demos on this repository, WasmEdge, Wasi-nn examples. So we will update the once we have the new demos, we will update them on this repository. And but in this presentation, we choose a image classification demo to present, and we use the MobileNet as our classification model. So let's get started with the demo. Okay, the first step. So the first step is in the Wasi-nn is loading the compare model. But before loading, So but the problem here is that for different deep learning backend, for example, OpenVINO or PyTorch, there are different deep learning backends. They may use the different formats to to store their model or to export their compare model. So for example, in OpenVINO used two builder files. So the first builder files storing the model parameters, and the second builder file storing the model structure. And Wasi-nn support variant length builder files as long as you concatenate those builders into one vector. So like we doing here. We trying to load a compare model into the OpenVINO backend, and we have the XML file, and we also have the bin file, which they stand for the model structure and the model parameters respectively. And we concatenate them into one vector, and we pass the pointer of this continuous buffer into the Wasi-nn. So that's how we support the variant length builder files in Wasi-nn. And also while loading, you also need to pass flags to specify backend and the target device. So we have some predefined flags in Wasi-nn. We can see in here we have a predefined flag for the OpenVINO backend, and also we reserve the flags for Onyx and PyTorch and sort of backends. Well, but we didn't support those backend yet. And also we predefine the flags for the target, for the CPU target, also for the GPU target. And so that's the first step. We loading the compare model into the Wasi-nn, and we create a graph. So this function will return a unique graph ID, and we will use that later. And I think, another thing to say is that before we actually use Wasi-nn in the Rust, we should first import the Wasi-nn interface into Rust, and we have a published creator for Wasi-nn interface, so you can simply add it to your Rust project's dependency and directly build it. The building tools for Rust, which is Cargo, will automatically download the interface. So, okay, the second step is much simpler. We create an executable instance from the graph. So in here we will use the graph ID returned by the load function, and we will return a unique context ID. So any computation is related to the context, not the graph. The graph is a way we can initiate a context. So that's the second step. We need a execution context. So the third step is to blind the input tensors into a context. In Wasi-nn, we have a general form of tensor. So if you look down the demo, in here we first read the image into a continuous memory in Rust, and then we wrap it into the Wasi-nn tensors. So that's the second line here. So we can see in our demo, RNG image, we try to resize them to a fixed shape, and then we pass that tensor into our context. So we accomplish that blinding by the set input function, and we can notice that set input function have actually 3 arguments. So the first one is the context ID, and the third one is the input tensor. The second one is, well, is the input index. So for some deep learning models, they may have multiple inputs, and we can use the second arguments to specify which input we are passing. But for our demo, for the mobile net, the only input for the mobile net is the image. So here the index is actually 0, and that's the third step. So the last two steps. Well, the last two steps. First, we will use we will call the compute function to trigger the actual computation. So that's you can achieve that by one line. You need to specify which context you want to compute, and then we can, and once the computation is finished, the result will be stored inside the context, and then we can use the get output function. We can call the get output function to retrieve the result into a certain buffer. So in here we try to retrieve our result into the output buffer here. In our demo, the result is a flow vector containing probabilities for 1,000 classes, because the mobile net is trained on a huge image data set called ImageNet, and the ImageNet has 1,000 categories. So the inference results will have like 1,000 classes, and each element representing the probabilities that you can have that object in your you may have that object in your image. So that's a walkthrough of the demos and demos code. So the final step is to build a Watson file, and we can use the cargo, the Rust's building tools to generate the Watson file, and also as we have mentioned before, make sure the Wasi-nn creators is added into the dependency, so you can pass the compiling successfully. And since the image processing is involved in our demo, we can also turn on the LLT mode in the WasmEdge to speed up the image loading process. That's the second command meaning here. And that's pretty much. And after that, we can run our demo. So the demo here is quite simple. We can see the output on the right here is the top five predictions from our models, and we can see that Wasi-nn correctly predict the main object, which is banana, in the image. So you can find out this more details about these models in the repository I have mentioned before. And so that's the demo's contents. And like Michael have mentioned before, Wasi-nn is currently implemented as a plugin in the WasmEdge, and so it's default to not building it because building WasmEdge will introduce too many dependencies. So if you want to use WasmEdge, if you want to use Wasi-nn in WasmEdge, you can pass a explicitly option while building. So in here we choose to enable the OpenVINO backend. But in the future maybe we will support more backends. But in a word, if you want to use the Wasi-nn, you have to enable at least one of those backend. And so once you have done your buildings, you can install the plugin with the CMake, and then you are all set. So that's the process to enable the Wasi-nn in WasmEdge, or at least in the latest WasmEdge. So and finally we will discuss about the future works for this branch. And right now for the Wasi-nn in WasmEdge, we only support the OpenVINO backend. And in the future, we plan to support more backends, for example, like PyTorch, Onyx, and TensorFlow. into the Wasi-nn. And also for the purpose of learning, more demos will be added. For example, I plan to add tasks like image detection or image generation using game, or probably we can introduce some models like transformers or LSTM from the natural language processing task. And one last thing is that probably we may also want to contribute to the Wasi-nn specification itself. So if we find out that any improvement we can make during our implementation in WasmEdge, we may also want to contribute to the Wasi-nn specification and maybe modify some APIs or add some APIs. So that's also a future work we want to do, but I actually didn't list it in this slide. And that's pretty much all. And thanks for your time. Okay, so that's all.
All right, thank you. Yeah, that's this is really great. As Jianbai has said, there's an example repository in our GitHub. That's maybe we can post a link to the chat. That's you can use Wasi-nn right now and use your favorite model and provide we have an image classification demo, and but you can do a lot more. So I really do encourage everybody to look into that and see what AI model you can use. I believe there's already another demo beyond the a mobile net image classification. It's a road segmentation. Meaning that's that's a widely used application in autonomous driving. Is that you take a picture of the road in front of you, and then you use AI to identify which is the road, which is a building, which is another car, which is bicycle, things like that. So you can have the boundaries of the road, right? So that the car doesn't drive out of the road, right? So that is also a very interesting demo. And also we have some demos from our TensorFlow users. So for instance, we had a collaboration with a project called Yomo, and what they do is a factory automation. So they have a data stream framework that takes those pictures that taken from assembly line. So they take like a couple of pictures per second on the assembly line. And what's on the assembly line is milk. So they put milk into those soft packagings, right? So those those paper cartons with a straw on it. And so there's certain way the product has to look, in order to be considered, not leaking. There's straw on it, and things like that. So they take that picture in high frequency, and then they use their framework to transport the image to the backend on the on the edge. Within the factory, they have another machine that runs WasmEdge with the TensorFlow extension, and they would look at the image and have it compared with the standard image, and then would be able to determine whether there's a defect product on the assembly line, where at which moment they would have a robotic arm to push it off the assembly line. Application like that, there's lots of those applications, and we'd love to see them implemented in Wasi-nn, because now we have a robust framework to do that at a very high performance. So I believe Wasi-nn can use the GPU like Mr. Ye has just said, right? So we want to see facial recognition and or just classification of different other objects, right? I always loved the food identification thing, because I have always wanted to do things like train an AI model of all the food I usually eat, right? And so whenever I go to dinner, or whenever I go to a meal, I take a picture of that thing, and it will automatically tell me what I have eaten the whole day, and then calculate calories for me, and then tell me that I'm eating too much, whatever, right? So that's so that can be tailored individually for each person, right? Because if you ask it to identify all the food in the world, it's maybe probably difficult, but I only eat like 100 different food, at most, right? So it can easily identify all the food in my plate, right? So there's lots of applications like that, and we'd love to see, how you use it. That's so that's why we have the example repository. So because all these are still in fairly early stage, so you might find things that are hard to use, or you may find things that are that I believe we already have identified some of those issues that we're gonna provide feedback to the Wasi-nn spec, so that we can improve that and make it more efficient. So yeah, that's I'm super excited for what to come next, and thank you, Mr. Ye. And so then let's get on to the last topic, which is community-based topic. And I met with Mr. Lambda and Mr. Sharma from when they came to Austin. Let me show you a picture. Here is three of us. Okay, so it's a proof that we actually met. We met in the Open Source Summit in Austin last 2 weeks, 2 weeks ago. So they came in town for Open Source Summit, and there's a lot of WASM WebAssembly related discussion in that conference. It's very exciting, and so we got together and we had we talked about the community of WasmEdge, and that's we thought it'd be a great idea to have a community ambassador program, and so we started with with the developer community in India, and and hopefully we would be able to expand to many other places all over the world. So I'll let Mr. Lambda and Mr. Sharma to talk about this in our next in the next segment of this meeting.
Yeah, thank you so much, Michael, and I'm really happy to be presenting with Mrityunjay. And yeah, as Michael mentioned, that it is really great to meet Michael in person. Of course, like all of us have been having these regular virtual conference talks and virtual meetups, community meetups. So yeah, hopefully we'll have these WasmEdge meetups as well in person very soon. But yeah. So I don't have a lot to present, but yes, I have created an GitHub issue. So let me just start by sharing my screen. Please let me know if you can actually see the screen. As Michael mentioned, that according to the proposal, we want to evangelize the WasmEdge community within India. Now, both me and Mrityunjay have been pretty active in the Indian developer ecosystem, and in the especially in the young developer or student developer communities. We have been part of various other student driven initiatives. And Mrityunjay, I mean, if you'd want to please just give a very quick introduction about yourself as well.
Yeah, thank you so much, Michael. Thank you so much, Shivai. Thank you so much, Michael, for meeting there in Austin. It was great meeting you. And as Michael mentioned, that we are looking out for evangelizing WasmEdge community. So a little bit introduction about myself. So I have been a student in India. I'm pursuing bachelor's in technology and computer science, and I'll be graduating in August this year. Other than that, I have been contributing to open source for about 2.5 years now. Previously, I've been a Google Summer of Code Scholar twice and an FX mentee also. So I've been quite involved with cloud native ecosystem and real-time operating systems. But yeah, we have also presented a talk with WasmEdge last year in KubeCon, if I remember, with Shiva only. So yeah, what we are thinking is about, as we know, the huge market India is, not only in supply, but also in demand. And as we know that it has a lot of students surplus, and students are one of the key inherent marketers of communities, because they are around 100K students graduating every year. So that is what we are going to discuss today in this proposal brought by Shivai, how we can help WasmEdge reach to the roots of this country as well. And from here, the ripple effect can help us expand more globally as well. So yeah, go ahead, Shivai. Thank you.
Right, thank you so much. So yeah, as Mrityunjay mentioned, that one of the biggest motivations for starting a developer community within India is the fact that India produces a lot of graduates every year. So we have a lot of young developers with relatively less years experience, but also a lot of students. And the other one is that Indians represent the highest participation in open source programs such as Google Summer of Code, Linux Foundation Mentorship, LFX program. So of course, it's a really good developer community to tap into, because some of the largest developer ecosystems and student programs are being run currently in India. Now, one of the other opportunities or scope where we can really tap into is the fact that over the past 1.5 years, there have been a lot of initiatives, especially within the CNCF landscape. So we have basically this entire cloud native students community that has more than 3,000 plus more than 3,000 members right now within India, and cloud native is seriously being picked up by a lot of students, by a lot of people who are just graduating. So there are a lot of job roles now where people are becoming DevOps engineers right after they graduate from college. So since the WasmEdge project itself is incubated under the CNCF, and especially a lot of students are now picking up Kubernetes, Docker, all these different technologies, serverless side. So WasmEdge sort of becomes an automatic pick, especially because of the fact that it is there to replace the legacy containers, right? And so we know that how WebAssembly containers are quicker than and smaller in size as compared to Linux-based containers. So being able to introduce topics like WebAssembly and WasmEdge will be a perfect mix, especially amongst these developer communities who are already well into the CNCF landscape. And it also sort of becomes very easy to then collaborate with these communities as well, in order to expand and to share about WebAssembly and WasmEdge. So what are the steps that we can actually take? So we can conduct workshops and sessions in various colleges in India and student developer clubs. As I mentioned that we have this cloud native students. Now KubeCon itself, which is one of the largest open source developer conferences, now has a dedicated student track, and majority of those students today represent from India. So there's a huge collaboration effort that can be run in order to introduce about topics like WebAssembly, because even today, even though WebAssembly has been there for quite some time, the adoption rate or the general understanding about WebAssembly is still very limited. But once we can come and expand upon what exactly is WebAssembly, what is WasmEdge, we can conduct some beginner-oriented sessions that will help expand the adoption. And again, the idea is that we really want these students to then come and join and become contributors for WasmEdge, and be part of, let's say, Google Summer of Code program or LFX mentorship for WasmEdge, because of course, the more contributors that we get, and especially young contributors, the better it is for the community as well. So we can conduct various sessions such as of course, these workshops, or even we can participate in other developer focused contests. It could be hackathons as well. And so those are some of the things that we can actually do. And of course, the outcome is to see more number of participants. So one of the things that we probably didn't mention within this specific thing is that what to do to get started. So of course, the first thing that we like to get started with is creating some content, creating some developer content with respect to how one can actually enter into the ecosystem, into the WebAssembly ecosystem, and especially start contributing to WasmEdge. So I believe that there is some aspect in which we can lower the barrier for new developers to join. So as part of this, I would like to concentrate initially on creating some guides or developer material for anyone to get started with WasmEdge, because of course with WebAssembly and with WasmEdge there is a certain level of involvement in terms of the technical capabilities that you need to understand WebAssembly in general or WasmEdge, right? So similarly, to enter into the CNCF landscape, you do require certain skill sets such as computer networking. So there is a certain barrier that needs to be lowered. So the focus initially would be that how we can share within these student developer communities to make these students understand the concepts of WebAssembly, WasmEdge, and then of course, proactively share about some of the beginner friendly issues, and just make it easy for students to be able to join, like, let's say, the WasmEdge community. So that would be one of the initial focus points. And then of course, once we have done that, we can start conducting workshops and sessions for WasmEdge and WebAssembly for students, and then see how we can have them interact with the community, and then of course start contributing. So that's basically a proposal. Of course, I didn't get a lot of time to sort of cover these points, but yes, the general idea is that we want to expand the ecosystem for WebAssembly within India. I think, because of the fact that we are now expanding so much into the CNCF, especially within students, it presents a really good opportunity to also add WebAssembly into the mix as students are learning about various CNCF developer tools. But Nitin, if you want to add something else to this, please go ahead.
Yeah, thank you, Shivai. So it was a great presentation, and even in the short time, I think you have pulled up most of the important and basic steps, just suggesting not only the problem but also how to solve it and what will be the outcome. So that is great. So one of my suggestions is that why we are focusing on students is that, first of all, most of the students in India are between the age group of 17 and 21. That totally, and they are mostly involved with right now Web3 technologies, and Web3 technologies are great, of course, but there's also a layer of over popularity on one side of technology, and trying not to digress from some underrated technologies that are in the pipeline and that can be the future, like WasmEdge. So that can be an essential focus for targeting those kids. These youngsters, not only they will bring us new point of view, new energy, but most of them will have more passion or enthusiasm to contribute as they will make themselves, as we will help them make them feel a part of something new and revolutionary. So that is one thing that will help us increase and expand in India, and from India in fact the world. So that is one thing. The other thing is, as we mentioned, as Shiva mentioned, we can organize community regional level hackathons, which will be surrounding the technologies of WasmEdge. So before organizing hackathons, we need to create that bubble of what is WasmEdge, and for that I think we can start with local meetups or local conferences before organizing hackathons, or maybe virtual conferences where even we can invite Michael, or demos like that happen today can be an interesting focal point for the kids. And maybe if one of us can start writing blogs, and if we share that on social media platforms like Twitter and LinkedIn that are beginner friendly, that lower the beginner barrier for the people who have started with cloud native technologies, that can really help us get more attention. Other than that, as it was mentioned in the proposal, swag distributions and swag prices, students love to get rewarded, right? So if somebody participates in our conferences or participates in our meetups, we can present swags to them, some of them, and they will definitely share it on their social media also, which will in turn create a net for other folks to join us. So these are also my suggestions, but it's a long path, it's a long journey, and we are looking forward to how we can contribute, because we have been part of Indian developer ecosystem for quite a while, and we can really help it push ahead with the help of all of you from here.
Yep.
Thank you, Shiva.
Thank you.
All right, this is excellent. Yeah, so we have a lot of contributors and community members in India, like Mashiraz here. On this call, he contributed to the to our entire WasmEdge installer. So the WasmEdge installer you see is written by him. And he's also working on our Python SDK. So we have we already got. What I'm trying to say is we already got a lot of very valuable contribution from India, and we'd love to see that community grow. And if there's, you know, and I love the idea of having conferences there. You know, that's I think I can travel there, and our other community members can also travel there. We'd love to go there, and you know, and it's post-pandemic, we'd love to go there and visit, right? You know, so yeah, that's yeah, you know, I think we really look forward to you know to the WasmEdge community to grow even bigger. You know, I think it's already very you know has made a lot of contribution, like I said, you know, but we look forward to see it growing even bigger under your guidance, you know. So that's yeah, that's you know, would love to see that. So yeah, so those are the 3 topics that we want to discuss today in a meeting, and now it's time for Q&A. So if there's any, so you know, so if you guys want to ask questions about the community or about Wasi-nn or about Wasi-crypto, you know, that's that'll be, you know, there'll be time to discuss that, or you know, as always, you know, we can use GitHub issues to communicate those issues. Yes, please.
Yeah, so I just had one question specifically for the proposal for Wasi-nn. So once I think during the presentation, Jianbai mentioned that we'll be adding support later for PyTorch models as well. So is that something that is currently being developed right now? It's in the works.
Yeah. Okay. Yeah. I think so, because while supporting PyTorch and Onyx is actually a plan. I try to accomplish in 3 months. So I hopefully, well, we can use Wasi-nn may support the PyTorch backend. Well, maybe in September or October. Well, I think we can support that. So actually not in very late future. So is that what you
Yeah.
your problem?
Yeah, I think that answers.
Yes. Yeah, right.
Yeah, that said, we would love to have more, contributors, and I'm sure when Jianbai wants more contributors, right? You know, so so if anyone wants to, you know, wants to contribute in that, you know, either implementation, you know, more hardcore stuff, or contribute examples, you know, we'd love to see that. You know, that's you know, people using our, you know, our frameworks and runtimes. Okay, so Brad asked, can we speak? Can I speak to the short-term roadmap for the next 3 months? Yeah, you know, so there's so one of the big push that we are working on really is, you know, because there's a lot of infrastructure stuff that's happening. You know, that's you know, implementing, you know, WebAssembly extensions. You know, on that front, perhaps the most important one is interface types. It's now called component model, and then the direct derivative from that is a bit bygen. You know, so those are the things that make host functions easier. So we want to continuously make host functions and plugins easier for WasmEdge, so that people can add to the runtime and extend it, right? You know, so that's one important area. So that integrate that with other projects. You know, so we are working on, you know, integrating with, say, you know, Fermion, Substrate. You know, we already have integration with Suborbital. You know, there's so there's lots of activities around that area. But you know, on the other end, that we are you know, we are really focusing on expanding the networking support in WasmEdge, so that it can be used, really used as a microservices runtime. So, you know, just think about, you know, how you if you want to use WasmEdge in a microservices environment, you know, have it managed by Kubernetes, or use it together with Dapper, or together with, you know, Service Mesh. You know, what you would need is that you would need to start a server in WasmEdge, and also have WasmEdge co-op to other web services, right? Today we have ways to do that with the Wasi socket proposal, but it's a little difficult. It's a little the APIs are too low level, so we are working on Tokyo support. So meaning that you can just write application in a way that Rust Tokyo API does, and then have a server application that compiled to WasmEdge and be able to have it run. We have preliminary demos on that already, and but on that, at the infrastructure level, we really do need to support HTTPS in this, right? Because there are lots of service frameworks that would only take TLS and HTTPS in production environments. So that's why we had such a big focus on the Wasi-crypto, because that's the basis for our HTTPS support. So so there are lots of very there are a lot of activities that would make WasmEdge a more I would say a more mature runtime for microservices. That would open doors for many other applications, because when you think about how AI inference applications are used today, it is used as at least in the edge cloud, it's used as a web service, right? So, and those web service SDKs have all kinds of different languages. So we work on Node.js, JavaScript support, and for Node.js APIs in JavaScript. That's the other thing we are working on. Those are all working toward one goal, is to make WasmEdge as a easy to use and a high performance runtime for microservices that people can use today to host their services. So so that's would be our big goals, but within that there's a lot of things that has to happen, right? There's improvements to the Rust SDK. There's lots of those improvements to the component structure, extension structure, make it easier to use, easier to install, easier to manage by Kubernetes, and so there's a lot of tasks that has to happen within that context. But our goal really is to make it a first-class citizen in a microservices environment, because we have seen this need more and more these days as people discover how WebAssembly can be used on the server side. They want to use it in a way that's people used to use Java, to write complete applications, and have them deployed or managed by their Kubernetes or by their service mesh, right? So yeah, that's so I think by the end of the summer, we would have I think we pretty much already have all the important WebAssembly proposals implemented, but by the end of the summer we would have even more, and we would be really being a good place, and maybe even have some important or large pilot users that would be using WasmEdge in the microservice environment as to provide serverless functions. Just to expand this a little, why socket and web services support is so important. So for instance, if you want to use WasmEdge to run serverless functions, you would want the serverless functions to have business logic, meaning to have access to database, right? How do you have access to MySQL database or to a key value database? The most typical way is through a socket connection. That means you need to port the MySQL driver to WasmEdge, which is, we have an open issue with for that, and we have people working on that. And the MySQL driver in Rust is written in Tokyo, right? So that in turn requires us to support the Tokyo framework, the asynchronous traits, and the network API underneath that, right? So with all that, that's so there's a whole chain of things that has to happen. And our hope, and actually my belief, is that we're gonna have all of it ready by summer. So that it's already summer, by the end of summer. So so we would be in a really good place to to support this kind of AI applications, microservices, database applications, all kind of things that people normally use.